In today's lesson, we are going to look at horizontally launched projectiles. That is, objects are thrown horizontally. The key to understand this kind of motion is a bit counterintuitive. It goes against your first instinct, but you still have to follow the physics approach. Let's just start with the first point. The core idea of analyzing project motion is to split the object's motion into horizontal and vertical motion. And how do you do that? You treat the object as moving independently in each direction. When you throw something horizontally, its path is a curve. Like when you toss a paper ball, it's a curve. To analyze it, you take its horizontal velocity and only look at the horizontal motion separately. And you take its vertical motion and only look at the vertical motion separately. That is a key to analyze the projectile motion. It feels counterintuitive because our eyes naturally see the whole path together. In real life, we rarely consciously separate motion into components. But this method really works and is very useful in physics. And now, about horizontal throwing, let me ask you a very important question. If I throw an object horizontally at 10 meters per second in the very beginning and ignore the air resistance, so what will its final horizontal velocity? It will still be 10 meters per second, because ignore air resistance, there will be no force horizontally on this object. So it will have no acceleration horizontally, which means its horizontal velocity will never change. And at different points, let's say A and B and C, their horizontal velocity is always 10. The horizontal velocity remains 10 meters per second at every point on the path. Because we ignore air resistance, so there will be no force in the horizontal direction. And let me write this clearly. So horizontal motion is uniform motion all the time. And that is our first key idea. So second, what about the vertical motion? In a vertical motion, is there a force? Well, yes, gravity acts downward. Whenever we throw something on Earth, we assume gravity is present because you're in the surface of the planet. So if after 1 second, the velocity becomes 10 meters per second, suppose the gravitational acceleration is 10 meters per second squared. So after 1 second, your vertical velocity would be 10 meters per second. And after 2 seconds, 20 meters per second. And after 3 seconds, 30 meters per second, and so on. So vertical motion is uniformly accelerated motion under gravity. So vertically it's more like a free fall with gravitational acceleration. And this points horizontal constant velocity and vertical accelerated motion and splitting the analysis are the foundation of understanding projectile motion. The hardest part is mentally separating the two motions, but it's what the theory is built on. And now let me give you another example. So suppose I throw an object from the same height h, first with a speed of 5 meters per second horizontally, and then with 10 meters per second horizontally. Does the time to hit the ground change? Does the time hit the ground change? The answer is no, it doesn't change. And so why? Because the time to fall is determined only by vertical motion, the height h and gravity g. Changing the horizontal speed doesn't affect the vertical fall. So it takes, say, 5 seconds to land. At 10 meters per second horizontally, it travels 50 meters. At 5 meters per second, it travels 25 meters. So remember, time of flight depends only on height, not on horizontal speed. And that covers the basics of horizontal projectile motion. It might seem tricky, but once you get the separate component idea, it makes sense. And now let's try a sample example. A projectile is launched horizontally from a height of 25 meters and it lands 50 meters from the base. What was its launch velocity? So still we can draw its path like this. It's a parabola. And the height is 25 meters and you don't know the initial speed, but we have known that its range horizontally is 50 meters. So how do we analyze this? So first, the time is not determined by its horizontal velocity. The time is determined by the height and acceleration. So height h equals 1/2 gt squared. We have known the height 25 meters per second, 25 meters, and we have known the acceleration. So t equals 2h over g to the power of 1/2, and we plug those values in the calculator. We can solve the time t. And after knowing time t, so the range of horizontal x equals vx times t. So vx equals x over t. We can also find the horizontal speed. So once you master this kind of problem, you're ready to move on the angled projectile motion. And hope you can review all the materials this class. And next class, let's get into this section.